we will do, we will check whether the actual output is correct or not. How can we define correctness? By threshold. So let's suppose our threshold at the first point we have set to 0.2. This one will be, if I set this to 0.2, this one will be 0 or 1. This one will be 0 or 1. I am saying if my value is greater than or equal to threshold, then it will be 1. This is 1. This one will be 0. This one will be 1. This one will be 1. 1. If I set this to 0.2, threshold will be, let's suppose, greater than or equal to. This will also make it as 1. So now we calculate how many of them are true positive, just like a confusion matrix. How many of you can do that? Actual is 1, model outputs 1. Actual is 0, model outputs 0. How many of you can do that? Tell me. Guys, confusion matrix calculation. This is actual versus prediction. You can? Yes, can do? Great. Something is wrong. I think I need to change my display, other display. Okay. Now we will do for some other threshold. Let's suppose this time I made it as 0.3 greater than or equals to. Everything except the last one will be 0. Same. This part is same. This one will make it as 0. Yes. So for each of this threshold, I will get a different TPR. I will get a different TPR and FPR. Yes or no? For every threshold, I will get its own TPR and FPR. So similarly, we will calculate this for all thresholds starting from 0.1 to all the way till, guys, threshold can all the way go from 0.0 till 0.0 does not make sense, but 0.1 till 1. Yes. So we will plot a graph, we will plot a point of each and every TPR and FPR, and then we will see a final graph. So now I will pick a data set. This is not a data set. This is just for an example of what we are going to do, and then we'll start it. Is everyone clear what is going to be the ROC curve? Is everyone clear what is going to be the ROC curve? Why my screen is flickering? Maybe I have to say goodbye. Okay, to the screen. Is it similar to beta in gradient descent? No, there is no concept of beta coety. This is just a simple calculation. This is a part of ML. This is after ML we use ROC and others. Okay. Okay. So let's start. Arun, for multi. Wait, guys. Guys, give me a second, okay? Okay, guys, let's not go to the complexity part. We have not yet went to the multi-class, even the probability part, right? So we'll talk about those later. But for now, how many of you are able to understand this threshold? Guys, threshold means we apply the threshold of 0.5 in the previous class. Yes or no? Just like that, we will keep on applying threshold for multiple things. Okay, I will show you. Let's pick a data set now. Okay, not a data set. Let's pick a simple data and start solving and see how the values will look like. Okay, how the values will look like. So I'm going to write now we are calculating the ROC curve. Arun, I'm covering everything. Did I cover multi-class classification, Arun? Did I cover multi-class classification yet? Tell me. Okay. Trust me. ROC curve. So what we are going to do for each threshold, we that is from 0.1 all the way till 0.9, because 1 is the final one. Everything will be 1. And if I pick 0.0, everything will be 0, right? It does not make sense. We will calculate two things. We calculate two things. First is we will calculate the TPR. Second thing is we will calculate the FPR. And once it is done, we plot true positive rate and false positive rate for all pressure. Done. Okay. Now let's see. Uh, let's draw the data. Let's suppose this is email, and email, this is the data. This is email number email A, B, C, D, E. We have 5 email and we have their true label. Okay. One is spam. Next one is not spam. So true label means one means email A is a spam, not a spam, spam, not a spam, spam. Okay. Model score. Model score is nothing but our y hat. Okay, that is our model score. For this one, the confidence is 0.95. This one is 0.70. This one is 0.60. This one is 0.40. And this one is 0.20. Okay. So what I'm going to do, I'm going to only plot for, let's say, 3 thresholds. Only 3. Okay. Threshold of 0.8, 0.6, 0.4. You guys can do all of those later. True label is Y. Yes, true label is Y. Okay, true label is Y. So actual spams are, how many of those are actual spam? Which of the following email are actual spam? A, C, and E. A, C, and E. And actual negatives, whatever is left, that is B and D. Correct. Okay. So now let's calculate the same for threshold 0.8. Okay. So for threshold 0.8, the predicted spam is 0.95. Okay. We will go to A, B, C, D, and E and try to check what is the value. Okay. So for threshold A, the spam value is, so let's calculate how many of them are true positive. When the threshold is 8, how many of them are true positive? This one looks correct. Yes. Okay, this one looks correct. And what about C and E? When the threshold is 0.8, only this one will be true. Yes or no? This one will be true. Only A will be true. So true positive, we will say only A. Let's talk about false positive. Do we have any false positive here? Do we have any false positive here? No. Okay, we don't have any false positive. If I talk about true negative, false positive is 0. If I talk about true negative, we have two true negative, B and D, because actual answer is 0. Actual answer is 0. And just wait. I think I have to write the final answer when I'm talking about threshold 8.0. Okay, guys, let me write everything. What is going on actually? It should be C and E, B and D. Great. I will explain one, then we'll just write all the others. Okay. So when the threshold is 0.8, this one will be 1. Okay. This one will be 1. This 0 confidence is 0.70. This one will be 0. 1 and this one will be 0. This one will be 0. This one will be 0. Is this correct? Does this look correct? Okay. So also let me write. Let me write this for because people forget. What is true positive? Model predicts correctly. Model predicts correctly. Actual is positive. Okay. So model predicts positive. Actual is positive. That is true positive. Okay. What about true negative? Model predicts positive. Model predicts positive. In actual, it's a negative class. Yes. In actual, it's a negative class. What about false positive? Model predicts negative. Model predicts negative. In actual, okay, wait. Yes. Model predicts positive here. Wait. Now this is correct. Model predicts negative, it's a negative. Model predicts positive, but in actual, it's a negative. Okay. Then final one is false negative. Model predicts negative. Model predicts negative. In actual, it is positive. Guys, read through this. I'm giving you 1 minute. This is what the actual thing should be. Okay. Please read through this. I'm giving you 1 minute. Let me know once it is done. Correct? Is everyone clear now? I'm keeping it on side. Okay. I'm keeping it here. You guys can refer it later. False positive and false negative are reversed. So false positive I've written that model predicts positive, but in actual it is negative. Guys, can you please check? I think this is correct. In false negative, model incorrectly predicts a class as negative. It means model predicts negative, but in actual it is a positive class. Guys, can someone please confirm this is correct or not? Someone said it is not correct. It is correct. Guys, it is correct. The definition I gave, it is a correct one. Okay. This definition is correct. Okay. So considering this as a truth, now let's quickly calculate everything. Yeah, nothing complex about it. So threshold 0.8. True positive. True positive, we have only A. The total count is 1. Let's talk about true negative. Model predicted negative, actual was negative. Actual is negative, model predicted negative. Yes. Which of these classes? B and D. So true negatives are B comma D. How many total? We have 2. Let's talk about false positive. False positive is model predicts positive, actual is negative. Let's see. Model predicts positive, model did not predicted any positive. This one will by default be 0. We don't have to even compare. Model did not predict anything positive other than this one. This one is already correct, a true positive. So this will make it as a 0 count. What is the last one? False negative. Model predicted negative, actual was positive. Model predicted negative, actual was positive. Yes, classes are C and D. Emails are C, comma D. How many of them we have it here? 2. Okay, we have 2 of those. So just like that, we will calculate. Okay, now it is clear. Guys, please revise all of this. True, positive. As I mentioned, these are interview questions. I don't have to answer in interview. You guys have. C and E. Guys, where is C and E? Oh, yes, C and E. Sorry about that. It is C and E. I've written C and D, but I wrote E. Okay, correct. Thanks, Mang. So now let's calculate the TPR. TPR formula is, see this TPR formula. TPR formula is, where is TPR? Yes, true positive by TP plus FN. FPR is false positive by FP plus FN. So whenever we talk about true positive, we are using FN. Whenever we talk about FPR, we are using FP and TN. Okay. So I'm just going to write it here, or just for the first time, I will write it again here. It is TP by TP plus FN. Okay. Let's calculate. TP is 1. TP plus FN, 1 plus 2. 1 plus 2 is, guys, what is 1 plus 2? 3. Answer will be 0.33. If I calculate FPR, FPR is false positive by, FPR is false positive by false positive plus true negative. That is the formula of FPR. If I calculate, what is the answer? Answer will be, I will show you by calculating it. FP is 0. So FP plus TN, 0 divided by 0 plus 2. 0 divided by 2, 0. Are we clear? So we got TPR and FPR for threshold of 0.8. Are we clear now? How do we calculate all of this? Is everyone clear? Similarly, we will create a threshold of 0.6, 0.4 and write down these values and calculate threshold accordingly. So now I'm just going to write the values of threshold, not going to calculate from scratch. Threshold is 0.6. The TPR we will get when the threshold is 0.6 is 0.67. FPR we will get is 0.5. Similarly, for threshold 0.4, we will get a TPR of 0.67. We will get a FPR. We will get a FPR of 1.0. Is everyone clear? Guys, are we clear? Now tell me, when I do the threshold, just from the calculation, when I pick a threshold of 0.0, the TPR will be, when the threshold itself is 0, TPR will be 0, FPR will be 0. You guys can calculate it. And when the threshold is 1, the TPR will be, 1. FPR will be 1 also. You guys can check it. Are we clear? So let me create these boundaries to differentiate these 4 categories. So now we have TPR, FPR of how many values? We have TPR, FPR values of 5 different thresholds. This is threshold 1. From starting from 0 all the way till 1, we have 5 different values of TPR, FPR. So let me write it like this. Okay. So for the coordinate, let's see the coordinate. When the TPR, I'm going to plot TPR like this. Okay. See this. I'm going to plot TPR like this, and I'm going to plot FPR like this. Okay. So for 0, 0, when the value is 0, comma 0, just wait. Yes. We have 1 point here, that is 0, comma 0. That it shows us threshold 0, comma 0. We have 1, comma 1. So the highest value we can get is FPR of 1, TPR of 1. So let's calculate. Let me do it here. Will we get a point like this? Everyone, will we get a point like this? This is for threshold. This is for threshold 1.0. This is a threshold of. And before writing threshold, let me write everything here. Okay. Let's write it, all of them as a coordinate of TPR, comma FPR. This one is 0, comma 0. This is for threshold 0. What is the next threshold? 0.4. For 0.4, we have. Okay, let's write in the sentence in the full one. Uh, Give me a second. Okay. This is 0.8. Okay. Let's sort it like this one. Threshold 0, then 0.4. 0.4 value is 0.67, comma 1.0. What is the next one after 0.4? 0.6. The answer is 0.67, comma 0.5. 0.8 value is threshold of 0.8 gives you value of 0.33, comma 0. And the final one is it a TPR, FPR? Yes, it's a TPR, FPR. And the final one is 1, comma 1. Yes, correct. Okay. So now let's plot all of them in a plot, and this will give us a ROC curve. This is a ROC curve of a single model. Okay. This is the ROC curve of a single model. No. TPR equals to 1 and FPR equals to 1 would happen if the threshold is 0, because the classifier predicts everything as positive. Let me check. Okay. Guys, let me check. Maybe these two values might switch. This one will be threshold 1.0. This one will be threshold 0. Let me double check. Okay. Let's do this. This is a rough. I just want to put it here. Let's see how many values we have for what. When I do a threshold of 1, maybe I just reversed it just for the number. When the threshold is 1, then on all the values will be 0. Yes. None of the values here are 1. So I think in threshold 1.0 only, we will get all the values as 0. Yes, because 0 divisible by anything will be 0. So I just flipped it. Thank you very much. Okay. Coety pointed it out. I have written it. I have reversed the values. For 1, we will get a value of 0, comma 0. For 0, we will get a value of 1 because everything will be predicted as 1. Okay. Yes. Thank you very much, guys. Thank you for pointing. When the threshold is 0, everything will be predicted as positive because every threshold will be greater than 0. It will be some kind of value. So we will ideally get TPR and FPR of 1 because everything is correct. And in threshold of 1.0, everything will be false, model predicted. Then we will get a 0. Yes, nice catch. Okay. The small thing we need to catch. So what are the things which we've already plotted? What is this? Let me erase it now. Okay. 0, comma 0 we plotted. And then let's kind of plot if this is 0.5. Guys, it is hard to plot. Okay. 0.25, 0.75, 0.25, 0.75. So I'm just plotting it on a guess. Okay. So we are done with 0, comma 0 and 1, comma 1. These are 2 points. 0, comma 0, 0, comma 0, and 1, comma 1. Now let's plot 0, comma 0.33. 0.33 will be somewhere around here, and 0. Okay. This is another point. Yes, false positive rate is 0.33 and the TPR is 0. Then we will get this point. This one is also done. Then let's plot 0.67. So 0.67 will be somewhere around here and 0.5 will be around here. So intersection of these two will give us this point. Yes. Then last one is 0.6721. So we will get this part is done. Then I'm plotting this part. It will give us a value like this. Okay. Then I will show you these are the points, and then we will ask our matplotlib on the general sense, connect all of these points one by one, and then finally we will get a plot. So we will get usually a plot like this. Let me show you on internet. ROC curve. Give me a second. Yes, we need to flip the axis. Okay. Then it will look correctly. Okay. Guys, TPR is usually on the y-axis. Okay, this is correct. This is TPR versus FPR. I will show you. Okay. See this. Open link in a new tab. And this is from Geeks of Gigs. And we are able to see we plot TPR here, we plot FPR here, then we join all the points that we have. Are we able to see this? Everyone? Okay. So we did the same thing. So ours will look like something like this. Not sure how whether we should join all, because here we did join all the components. So let me show you a few or more examples. But from these points, we just plot a curve. Let me show you a few more examples. From this part, we don't generally plot it, but I just want to check how all of this will get connect. Easy to remember? Yes, correct. Guys, my coordinates are wrong. Did I plotted a wrong thing? 0, 6, 7. Oh, okay. Sorry, I plotted a wrong thing, right? This is, I was looking at something different. This data is correct, right? Everyone, this part is correct. 0.33 was a part of TPR. So our X is TPR only. This is TPR. This is FPR. This part is correct, right? So now let's try to plot it again. Yes. Okay. Not sure why I did it. Okay, let's quickly plot it. Let's complete this fast. Guys, what do you mean by flip it? I cannot flip. Yes, TPR is y-axis. Oh, okay. Got it. You want to say like this. Got it. So guys, if the TPR is y-axis, I have written TPR as x. Okay, so let's just flip it. The same thing. What I'm going to do? Yeah, got it. I've written it incorrectly. That's why it is creating a confusion. So now let's create it fast. FPR is x-axis. Okay, this is FPR, and then this is TPR. Now it is correct. It was already correct before, but I've written it not like the x and y axis. What was the value? The value was 1. Is it correct now? Just from the axis point of view, it looks correct. Yes. That's all. Now this is FPR. Same thing, guys. Same value. Nothing was wrong before, but this will help us plot better. Okay. This is our x-axis. This is our y-axis. All right. Easy to draw. Then we will connect all the points. If I don't write it correctly, I am plotting incorrectly as well. So let's quickly plot it. When the x value is 0, everyone, when the x value is 0, the answer is also 0. When the x value is 1, the answer is 0.67. So let me just write few things. This is 1, this is 0.5, this is 0.25, this is 0.75. This is 1, 0.5, 0.75, 0.25. And let's quickly plot it. Next answer is 0.67, 1 intersected with 0.67. I'm plotting it here. So this is second. We have plotted first and second. Let's plot 0.5 on the x-axis, 0.67 here. It looks like this. Next, when the answer is 0, on y-axis we are getting 0.33, somewhere around here. Okay. When the answer is 0, when the answer is 1 here, the answer is also 1. This is already plotted. Yes. So now it looks correct. Everyone, see the graph now? Are we able to see the graph now? Yes. It does look like a curve now. This whole thing is ROC. This is ROC curve. This curve which we are getting is a ROC curve. 1 comma 1 is not plotted. Okay. Let me plot 1 comma 1 as well. I thought I plotted 1 comma 1, but okay. This is 1 comma 1. Mine does not look correct, but because this is not a real plotting environment. Okay. Something weird like this will look. All right. Because usually if you check on internet, the plot really looks like this. We don't create a curve. We create lines from it. Line, 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 line. See this plot. I will show you one of the image. Ours also looking like this little bit because we are not putting for all the thresholds. We've only calculated for 3. The more we will calculate, the more fine our ROC curve will look like. Are we clear now? Everyone? To see this, what they are doing, they are plotting multiple models ROC curve. This is model number 1. We trained with some of the parameters. This create a model. We trained with another model. This creates a different one. What is the ideal one? Our ideal is our model should have less false positive and more true positive. So ideal is 0, 1 point. Are we clear? Ideal model should look like this or should reach to that level. Okay. Yes, where TPR, what we want is TPR should be greater than FPR. Our TPR value, in this current sense, our TPR value is only having, when the value of TPR is 1, our false positive is also 1. We want a scenario, guys. Which threshold is best here? Tell me which threshold is best here. We want TPR to be bigger than FPR. Here we see TPR, but our FPR is also high. Here we see a higher TPR where FPR is also low. Yes or no? Which threshold it is? What threshold this value is? Are we clear? If you check 0.8, 0.8 was the one where TPR was 0.33 and FPR was 0. So we want our TPR to be bigger than FPR. So we want our model to be in this range where FPR should be present here and TPR should be high. Are we clear how ROC curves help us plot things? Okay, now we are able to cater which threshold we want. Even from this value, we are now able to understand which is the model we want. We want a model where TPR is higher than FPR. In this case, TPR is higher, but FPR is also higher. False positive rate is also high. Here TPR is 1, perfect. False positive rate is also perfect. So using ROC, we are now able to find the threshold which we need to apply to get the output. Are we clear? And when we use this value to plot, that plot we call it as a ROC curve. That's all. So I know it is little bit time taking to understand ROC, but this is what ROC is. In interview, lot of the people, I will say around 8 people out of 10 people don't know what actually is ROC. This is what ROC is. Done? Is everyone clear on ROC? Is everyone clear on ROC? Yes. Guys, we do this one. We calculate the ROC values on our test set. Using our test set, we will be able to find which is performing better. So using ROC, we find the threshold. If we don't want to use a threshold of 0.5, I will not suggest to go with a threshold of 0.5 because in our case, we are able to find threshold is 0.8, not 0.5 for the perfect model. And this is a plot ROC of one plot. Let's suppose for a different model. For a different model, we will get this different TPTN, yes or no? For a different model with different parameters, let's suppose for this model, we use a split of 80-20. Another model, now this is a model number 2. We did 95 and 5. 95 on the training set, 5 on the test set. How 0.5 is 8 is calculated? Guys, we have covered everything. Now you're saying how 0.8 is calculated. 0.8, this is my actual data. I made a threshold of 0.8 and then calculated things like this. Sayed, do you remember now? Guys, let me do a quick recap because I think you guys are forgetting. So ROC curve is calculated on TPR versus FPR for all possible threshold. Our actual answer is Y. Model predicted these as probabilities. Now for each of this threshold, we can get a different TPR and FPR using because every model has different true positive, false negative, and true negative. So we will get something like this. Okay. We will get for each of this threshold, we will get a different TPR, FPR. Similarly, what we did, we calculated only for 3. We did everything manual. We calculated for 3 thresholds only 0.8, 0.6, and 0.4. And we got TPR and FPR rates. Okay. Then what we did, we calculated it and try to find that on this one in terms of graph also we want to find the ideal one. We want to find the less FPR and the highest TPR. That is our perfect model. So perfect model we are able to find here and we can also see it here. So this particular threshold, this particular answer 0.33, this TPR versus FPR we found from which threshold? If you check, when the threshold was 0.8, our TPR was 0.33 and FPR was 0. So this is the coordinates this is the coordinate from threshold 0.8. So 0.8 becomes the threshold of our model. Are we clear? So guys, always make sure that our real world is test set, not training set. Okay. Our real world is test set, not training set. It has to perform good on training set, but test set is the main goal. Okay. So let's suppose this is model one. This is with 80 to 20 split. Now we have another model. Let's suppose we have another model and we are getting a graph like this. For another model, we are getting a graph like this. Which model is better now? Which model is better now? Yellow one or blue one? Which model is better now? This is a model with 95 to 5 split. Yellow is better because we can see the higher TPR as compared to the previous one. FPR is also low. So this one is having 0, comma, whatever the value, 0.66. So we need to check what threshold this was. So using graph, we are able to conclude it. Graph help us see it correctly, all of the information in a single place. Nomesh, guys, what is the point of plotting this coordinates into graph? We can deduct the answer from here, but graph help us compare multiple models in a single place. If I have 10 models, I will see 10 times 5 of this information. I will see 15 different answers. But in graph, using different colors, different coordinates, I will be able to find which model is better. Yes, correct, Alok. Are we clear, everyone? What is ROC curve? Why do we need ROC curve? Is everyone clear? Anand, first we check the comparison with guys. We only plot if our train set ROC, guys, ROC is going to do any comparison. This is after performance evaluation. If our train is saying, let's suppose 87% accuracy, then what you're going to do within this train, now you're going to check from the ROC. Let's plot ROC on the training set and see what threshold is good. Let's suppose this one we got from the by default threshold. After applying a threshold of 0.8, our accuracy is still 87, but it does the changes in precision and recall. Maybe we are getting a higher precision and recall as compared to the previous model. Then which threshold is better? By plotting the ROC, we are deciding which threshold to pick. Maybe accuracy is a little bit better, only 89%. But we are seeing an increase in precision and recall also. So using this step to improve even your training means you're picking, if you improve your accuracy in training, you're also improving accuracy in the training set. Possibility. Yes? Are we able to understand now? Everyone? New threshold is going, see, by default there is some threshold, guys. If we don't want to use any threshold, by default 0.5 is there in logistic regression. If we want to create a new one and test whether a threshold, by changing a threshold, it is improving my accuracy, then change it. That is the test for us. So ROC will help us because we don't want to test one by one. Guys, do you want to test your model for 0.1, again train and test 0.2, again train, test 0.3? You're going to plot everything and then see directly. Because you already have the probabilities here in the first set. Why not plot ROC and check everything in a single go? That's what ROC is. Are we clear? Great. Okay. Now see this. Which particular graph has a bigger area? If I talk about area, let's plot the blue one. This is blue area. Which particular plot has a higher area? Yellow one. Okay. So we are also able to find, if I talk about the area, if which area is bigger. If this is 1, 1, this is 1. Everyone see now, I'm going to the next topic. This is next topic. This is coordinate. This is FPR. This is TPR. Give me a second. Okay. Okay. This is my TPR. This is my FPR. Okay. Out of these two, can I say the rectangle yellow one is having the higher area? Yes. Rectangle yellow is having the higher area. Yes. And when the area of another rectangle is lower than some another rectangle, it also means the performance of that one is low. Yes. The performance of that one is also low. Okay. Same thing is called as AOC. AOC is a numerical value. Now see this next part. Next topic is our AOC. The full form is area under ROC curve. Whatever the area that we are able to see here on the ROC plot, that is nothing but our AOC. So AOC is a method to get a single value of the ROC curve. Okay. So it is nothing but a numerical value of the area under ROC curve. So area under ROC curve is AOC curve. Okay. If I talk about how to read this AOC curve, whatever the value is, that is what it means. Probability that the model ranks a random positive higher than random negative. Now I will talk about how to read this statement. First, read it. Probability AOC curve will give you a number, which is again in terms of probability. Okay. So probability that a model ranks a random positive higher than a random negative. Negative means class 0. Positive means or positive means a class of 1. Okay. So if a model ranks any positive number, any one higher than any negative, then that model is better. It means there is some differentiating factor between a positive and a negative data. If your model is able to differentiate more, it means that model is better. Okay. So just giving an example, this is not the right example, but I'm going to give you which one is better. You guys will tell me. This is model number 1. Model number 1. This is model number 2. And this is model number 3. Tell me, out of these 3 colors, which model do you think is able to differentiate the data better? Differentiate the positive and negative data better. Red. Red is able to differentiate this whole part. As I mentioned, this is just for intuition. Red is able to differentiate this whole part better. You can see still there is a red line, but blue one is able to differentiate this plot as well as this one. So this one is blue one is little tight. Yellow one is again not too directional in the terms of that, but red one, it is taking the directional of both the data and also having some gap in between. gap for other data also. So it is a better fit as compared to others. So AOC curve will also give you something like this. For a model, it might give you 1. For another model, it might give you 0.7. 1 means your model, the probability that a model ranks a positive higher number, other positive number higher than negative number. So it is able to differentiate better. The more the number is, the more the probability